Hi, my name is Dirk de Haar. I'm responsible for our international business development at SMIGHT, and today we're looking at how we perform transformer monitoring within our system. Why is it important to look at transformer monitoring? If you already know SMIGHT, we come from the world of feeder monitoring, and so transformer monitoring is a slightly different topic, and that's why we want to look at it separately. And we have three distinctly different ways of performing the transformer monitoring, so we want to help you understand what's the difference between those different methods so you know what you're seeing in our system. And why is transformer monitoring important in the first place? Well, of course, transformers are one of the biggest assets in the low voltage grid, both from cost and also the importance that they play. So being able to monitor and understand what's happening with your transformers is obviously of central importance. Through this video, we're going to look at both how we set up and manage the transformers in our system, but also how the measurements themselves are either calculated or measured directly in the system. So we have three different ways of monitoring the transformer. So the standard way that you'll get with every configuration with SMIGHT is that we have our gateway, which is taking a voltage measurement from one of the bus bars, and then you have all of your current measurements being taken directly from the feeders. Now, we're taking both current magnitude and direction and phase angle. So when we combine those two, we can get not only just the power in and of itself, but we have the real power differentiated from the apparent power. So out of the box, you can have that, but it's important to note this is an estimate because you don't have all three voltages in that scenario, so you don't know exactly what the power flow is on each phase. We're going to take the one voltage and assume that the other voltages are the same. And also, if you don't monitor all of your feeders, then anything that's happening on a non-monitored feeder will actually flow or distort that calculation. So that's the one level. You'll have an estimation, and that will probably be good for most situations where actually the feeder level monitoring is more important, to have an estimation of what the load is on the transformer. And the next level of upgrade we can offer for that is our voltage sensor. Our voltage sensor essentially enables you to measure the other two bus bars at the same time. So you have all three voltages. And again, you'll have your current data from the feeders, combine those two, and you can have your power differentiated between actual power and apparent power. But it's still calculated, but it's just much more accurate because we have all three voltages. And the next level up on top of that is our Connect UMG product, where we're actually creating a connection to a transformer monitor. So the transformer monitor is already getting the data directly from the transformer. We're simply reading it out and communicating it into our gateway. So that's the most accurate because you're getting the true value directly from the device itself. So three levels: one level of estimation with a reasonable level of accuracy. You can improve that accuracy with the voltage sensor, and then you can get a direct monitoring point. And it's really up to you as the network operator to decide which one makes sense to operate where in your network. So where a rough estimation is more than enough, and that would be the place to use it, but maybe where you're closer to the edge of the operating envelope, it may make more sense to monitor the transformer directly with accurate measurements. So now I'd like to show you how we can set up the transformers within the back end of our system. We call this our device admin. So starting from this page, in the top right corner, I've got the Add Station button. So by clicking that, I open up the first page. The first option that I have is to choose between a local network station and a cable distribution cabinet. Obviously, in this context, it makes no sense to do this with a cable distribution cabinet. That wouldn't have a transformer in, so we're dealing with a local network station, so a secondary substation. I select that first. Then I can enter the information about the station, such as its name, where it's positioned in my grid, either via an address, or you can use geolocation data. And then in the second tab at the top here, we've got the configure structure. And this is where we need to put a little bit more thought into what's actually in the substation. So I could either have two separate transformers, each with their own low voltage distribution panel, or I might have a single transformer with two distribution panels separately. So I need to think about which one I'm actually configuring when I do this. So the first thing I have to do is to create the transformer. So by clicking on the Add Transformer button, I can rename it in this General tab, but the most important bit is the limits and thresholds. So here I can set the power. We have a few standard settings in there for most common power, but if I had something else, I can put that in. So let's say it's 700 kVA. And then you'll see on the right here, the threshold is automatically set. We set that at 80% of the power rating that you put in. And then I can put in the fuse rating. So let's say this was 1000 amps, and then that does exactly the same. And you can override that. So we're setting it at 80% just because that's the value that we get. Most feedback from our customers makes sense. But if you want to set it at something else, then feel free to do that. The thing to bear in mind is that this will impact when you get notifications. So you're going to get notifications when you go over this threshold. So setting it too low could mean you have too many notifications, and setting it too high might mean you get the notification too late on a critical situation. So just bear that in mind, that that's the trigger that you're going to have. Then at the bottom, I can set exactly the same with the voltage. We take the standard plus minus 10% values in there. If you want to set those again at a different level, you're free to do so. Then I can click Create, and that's created me a transformer. Okay, so I've set up one transformer, and now I'd like to set up a second one. I can do that by clicking Add Transformer here. And once again, I can go through and set the values. So this time I'm going to pick them out of the menu here and set that at, let's say, 500 amps and create. So from here I can then create the low voltage panels. So for the first transformer, I can do that here. We have two ways of adding multiple feeders. You can either simply click through here by adding them like that, or I can show you on the second one here, I can also add multiple at once. So if I know I've got 7, I've already added 1, then I'm just going to add 6 in here, and then that creates all of them in an instant. And just like with the transformer, I can put in descriptive information about what I call the feeders. Again, it would make sense to take that information from your GIS data, and then I can set the fuse rating, and once again the threshold will be set at 80% of that fuse rating, and you can adjust it if you want to. Now I've had the other scenario where I have 2 low voltage panels but 1 transformer, and if I've done that incorrectly I can get rid of this second transformer, and then I can simply add another distribution panel, and once again I can use the button here to add feeders on. So that's what that would look like if I had a single transformer, 2 low voltage distribution panels, each with 4 feeders. That would be that setup, and then we'll be good to go. So now I'd like to show you how the data is actually represented in the SMIGHT cockpit. Here we want to look at the ways that you can see the difference. So we have a number of different ones set up in our demo environment, and in there you can play with this. All of this is available online, so you can follow this yourself if you wish to. So for this first level of having a gateway, taking a single voltage measurement and then taking the sum of the feeders, I can see that in the demo industry could be best. I go into there, go and show substation. And so I can see here I've got a transformer at the top. And again, those values that you set are being shown here. And then next to the power, it shows me the transformer current computed. So it's telling me that this is a calculated value and not a measured value. And across the top here, I can switch between power, load, and voltage. And here in voltage, we can see there's only 1 voltage being measured because it's a gateway taking 1 voltage. And in the setup process for the gateway, the installer indicates which phase the gateway's been connected to, and so that will be correct here. So in this case, it's L1. And I cannot select the other options, so I know that that's the case. Now let's look at the 3 voltage variant. So in your version, if you're looking at this online, you want to go to the demo ZKM variant, which is in the middle of the screen. You can go into here, and here I can actually select the voltages. So that's the key differentiation here. In this particular example, it's actually in a distribution cabinet, so I don't have a transformer. So there's, again, a differentiation point, but it looks exactly like this, that you can then make those choices. And then the final variant is if I have a connect UMG connected and therefore taking direct transformer measurements. So then I need the one in the top left, which is demo Gutenberg Platz. When I go into there, I can then see a configuration where I have 2 transformers, I have 2 distribution panels like we did in the setup demonstration. When I'm at the station level, I can just see a summation of the currents, but if I go into the transformer, it then looks different. And here I can then see the power, I can see the apparent power and the actual power, and I can filter between those. And when I go to the voltage, just like with the 3-phase voltage sensor, I have the 3 to choose from here. But the key difference here is that this is a measured value and not a calculated value, as we went through before. So hopefully we've been able to show you the way that we approach transformer monitoring. So just as a short recap, we offer 3 different ways of capturing this. The standard way being taking a single voltage measurement plus the sum of the currents. This will give a good enough estimation for most use cases. And then if you want to add accuracy to that, the first level would be to take 3 voltage measurements, and then the final level to be able to take a direct transformer monitoring measurement, and then you can use that for your transformer monitoring across your grid. So here you've seen an overview of our different transformer monitoring solutions. If you'd like more details about the voltage sensor or the Connect UMG device, we have got separate videos for those, which you can find either on our website, in the media library, or on our YouTube channel.